here are the goals we've established. I am very quickly going to introduce the concepts of environmental security, which many of you heard. That is the theory of how the environment can cause instability and insecurity in the world. For example, water is a scarce resource, is an environmental security concern in many parts of the world. If you don't believe me, ask people who live in western Kansas and try to grow crops today. That's an environmental security issue. Climate change is one of many, and we'll go over those really quickly. But you need to understand the fundamental and the foundations of an idea before you can look at the specifics. That's why I'm going to cover environmental security. We will cover some of the current science on climate change, and I'm going to update you to the late 2018 data and analysis that's been developed, particularly that was published by all the organizations in the United States government and signed off by the White House. Then we're going to start looking at the human health and the effects on humans. And Rick is going to go over and put the pieces together. Here's the science. Now here's the human impact of that. We're going to use an example of the Tibetan Plateau. You've heard me do it before, but we're going to look at it from the human side, not just the national security and the world security. And then we're going to consider a future. It's going to be our choices that are going to determine that future, but we want to look at some of the options that are available to us. And there are options that are available to us. So that's the agenda we're going to try to achieve in the time that we've got. So obviously, I used to say that's me in the back, but it's Rick. But you can see he's a whole lot bigger than me there when I introduced this. Many of you have seen this before because I like to use this. This was in the Kansas City Star in 2014, right after the United States Department of Defense published its climate change roadmap. What the Department of Defense felt it needed to do to start reacting to the climate change it had already seen and the most conservative estimates of where it was going to go. That was published in 2014. You'll see in a couple of more slides where we are right now within the Department of Defense in looking at climate change. And of course, I used to say that was me, but I have here a quote from General James Mattis, who unfortunately was the Secretary of Defense and is no longer in that position because he was doing a brilliant job at it. But in his congressional written testimony, when they were just reviewing his credentials to be the Secretary of Defense in Congress, these were some of the things he wrote about climate change back in 2016. Climate change is impacting stability in areas of the world where our troops are operating today. And he was particularly talking about where we operated in combat. To update where we are today, this is a book that isn't out yet, but I'm going to get a copy. I was asked to review the book for one of the military journals. All Hell Breaking Loose, the Pentagon Perspective. What Michael Clare has done is he has gone and interviewed people throughout the leadership, current leadership in the Department of Defense, and looked at the historical records to see what the Department of Defense, how it views climate change now and in the future. And the title is correct. We see all hell breaking loose for the Department of Defense, both from an operational standpoint and the security threats that climate change is going to cause to grow and grow around the world. So, in one instance, we've kind of won one battle. I spent 25 years trying to talk the Department of Defense into considering climate change along with the other strategic threats that we face. Nuclear weapons, proliferation of military weapons in the wrong people's hands, those kinds of threats that we're concerned about. Now you will see the Department of Defense looking at climate change and its impacts in different places in the world in the same vein that it looks at those. That doesn't say it's bigger or larger, but it's one of the threats that we must consider from a national security standpoint. And that's what this book Oh, it went all the way. What is it? Oh, I'm all the way at the end here. I must have had the button locked down. You didn't even tell me this.
Speed reading.
There we go. Let's get all the way back. Okay, there we go. So this book, I think it will be on Amazon within a month or so. If you're interested in it, like I said, I've been asked to review it, so I can't say it's a good read or a bad read. I looked at all the chapters that were there, and it's got some really interesting information. So if you're interested in that thing, I think it's going to be like $15 on Amazon. If it doesn't sell well, wait. Maybe you can get it cheaper. All right. Please.
Does the Pentagon have a unified perspective, or would the Navy have a different perspective than the Army?
You have to understand the way we're organized to do that. Each of the services has their view of things, but the thing that really matters, as far as I'm concerned, is what we call the combatant commanders. We take the whole world and we divide it into 5 equal slices. And a 4-star general, it may be an Air Force guy, it may be a Navy guy, maybe a Navy will always have the Pacific. Army and Marines and Air Force, we kind of scatter around. Those guys have to write their own strategic analysis for their region of the world. I'll give you an example. Before North Korea went crazy and started building nuclear weapons, the guy who owned the Pacific Command, a Navy 4-star admiral, had climate change as his #1 risk factor. Now it's #2, and #1 is North Korea. Weapons of mass destruction and nuclear weapons. That's kind of the way it should go. So what I'm telling you is each one of those COCOMs have their own strategic analysis of climate change. They've already thought their way through it. I have worked with the European Command and the folks there. I'm sure every one of them has an environmental security person on their staff that works with that along with the other risks that are available. So that's really the most important place. It is in the Pentagon, but quite honestly, they're having great difficulty right now. Let's be honest, they work for the President of the United States. We serve at that. So you will see it, it's not as visible there. But Congress still gave them money to study the impacts on security of climate change, and they're still spending that money. So it's going on, but the real important work to me is done at the COCOM level that are doing the strategic analysis. For example, of the Tibetan Plateau. That's in the PACOM area. You'll see why that was #1 in that particular area. Good, thanks. So, I always point out I didn't invent this. Scholars at Oxford, Cambridge, and Yale, a few other elite universities were studying this back in the 80s. That means this work started in the 60s and 70s. And this is the best quote I've ever seen that really concisely describes what environmental security is about. And I always like to emphasize by reading, which I don't read your slides very much, but national security is not just about fighting forces and weaponry. It relates to watersheds, croplands, genetic resources, climate, and other factors that rarely figure in the minds of military experts and political leaders. Published in 1986 based on work that was done well before that. Climate, even at that time, certain scientists were recognizing it imposed limitations on people that did become security problems. Sometimes, I guess I'll do it here too, I also quote a wonderful military scholar, a guy named B.H. Liddell Hart, who was a World War I kind of strategist for the British government and a scholar. And B.H. Liddell Hart's quote was, "The only thing harder than getting an old idea out of a military mind is getting a new one in." And I looked at that as my challenge when I was dealing with the Pentagon and trying to convince them that they need to start thinking about climate change in the same way they think about other threats and risks around the world. But that's why I consider this a bit of a win, because we've gotten way past that now. So, this is the definition that we will work with for the rest of the evening, and that I finally, after years and years of my research, have I found dozens, actually 33 different definitions of environmental security in my initial research. But to me, it gets down to this, and I'll let you read it. With the double and triple underline, providing people their basic human needs. And that's how Rick and I are linked together.
And it's important to realize that when we're talking climate change, we're not talking about just a single object or a single process. It's like a fabric, and it's interwoven into all these other events, all these other processes. And so if you pull on one thread, then others will unravel, others will tear. And so you'll affect many different areas out there by what's going on with climate change. The other thing that's important to remember, particularly when we're talking about human needs, is that climate change is going to predominantly and first affect the poor. And so it really becomes a big social justice process.
So what I put up here, we'll go back and forth so we don't leave out the folks over here. This is kind of a synopsis of all the different issues that could be environmental security. Water is a scarce resource. When I started that, that was the one that was obvious to me that was going to dominate the next 10 or 20 years. And it's continued to grow in the problems that it can cause. In fact, a lot of the work I do is just focused on the water because it's an immediate problem for billions in the world. There's 2 billion people that don't have clean water and get sick from it. More than 2 million people a year die from dirty water, just because of that, from the diseases that are carried in dirty water, according to the World Health Organization, the last numbers I saw. Air, climate change, El Nino, La Nina, ozone depletion. Yeah, we won that battle, but we have to wait 100 years for the result, because just like greenhouse gases, the residence times of those chemicals in the environment is up to 100 years. It takes that long to complete the cycle, even when you completely stop producing the stuff. And that's one of the lessons we have to learn from ozone depletion and apply it to the greenhouse gas solution sets that we look at. So the longer you wait, the worse and worse it's compound interest that we're paying in the damage that it's going to do in the future. And in many places in the world, land issues dominate. Deforestation, loss of arable lands, and those kinds of things. Waste disposal in many places in the world. The amount of contaminated materials that are dumped, toxic materials that are dumped into the water and into the land that work their way through the food cycle and then become chronic issues for people for long periods of time. In many places of the world, that's not a problem. It shouldn't be in the United States, but if we keep reversing the environmental laws that we have put in place over the last 50 years, then we'll be back to looking at things like Times Beach and let's see, what are some of the others? Yeah, you all name them. You all, yeah. So we need to think about that as we make these rapid changes in things. We're going to spend our time on climate change, but it's important to recognize that all of these are in place. And the other thing to recognize is climate change has significant issues on water, significant issues on air, and significant issues on land use. It reduces arable lands in many places in the world, as an example. So that's the woven fabric that we're talking about here.
So climate change really brings about a number of really big impacts onto the people. They range from the extreme storms, which is something that with Heart to Heart that I respond to a great deal. Those will result in basically loss of life, loss of economic activity, loss of agricultural production. And when that happens, since that can happen with tropical storms, it can happen with more prolonged ecological disasters such as droughts or even more rapid ones like floods, then it results in increased poverty. And what happens with that is that the poverty becomes a trigger for conflict, it becomes a trigger for migration. And when you migrate, then you have more chance for social disruption and conflict. And in particular, it can destabilize some of the more stressed economies. And it affects directly some of the aspects of conflict as well. When we responded to Typhoon Haiyan in the Philippines, we were out working on Samar Island, Samar and Leyte Island. And really, unbeknownst to us, there was still an active guerrilla conflict going on Samar Island. And what happened was that the guerrillas were affected as much as the rest of the population was by the storm, and they started attacking the aid convoys coming through. So you had to, this is truly a climate change driven storm, and it was increasing the conflict because it put the combatants under stress. Particularly with the heat is, it reduces the resilience of the population. Anytime it's really consistently hot, people are not going to be as healthy. It has all sorts of other effects in terms of increased evaporation, loss of agricultural productivity, and that produces more malnutrition. But it's also a direct effect on economic activity. And economic activity is projected by the year 2100 to be reduced by about 25% in South Asia, Southeast Asia, and East Asia. And that produces more poverty, which will produce more unrest and increase the likelihood of conflict. Water and foodborne disease are certainly real common, particularly but it increases in the settings of climate change-driven disasters. So in Hurricane Matthew that struck Haiti back in 2016, it resulted in, basically, it eliminated all the agricultural activity in the southern half of Haiti, in the southern peninsula of Haiti. Wiped out all the food stores. People were just absolutely hungry. We were down there, and people were ambushing food convoys that were going along the road because they weren't getting enough food quickly enough. And what that resulted in was decreased resistance to infection by the people there. And so what happened then was, well, cholera reared up. And so cholera took off, killed probably, they don't really know how many people, several thousand. And a lot of it was due to the change in the water cycle and the decreased resistance in the people. You also run into other problems, flooding, particularly like in Pakistan, after they've had their floods. Vector-borne disease, malaria, is something that will crop up in those areas that are malaria prone after hurricanes and after tropical storms that are climate change driven. There's a thing they call the mosquito bloom that occurs. Actually, a lot of mosquitoes are sort of literally blown away by the storm, but enough of them survive that when they start coming up again about 2 to 3 weeks after the storm, they are just all over the place. They are really increased, and one of the things that happens, they decrease the mosquito's reproductive cycle. So they will hatch in about 1/4 to 20% less time than the egg normally incubates. They come out significantly smaller, they have less energy reserves, and they come out hungry. And they will just go and bite like crazy. Yes?
What causes dengue fever?
Dengue fever is a viral infection that is caused by, transmitted through the bite of the Aedes aegypti mosquito, and so it's a mosquito-driven one. Dengue is another one that can spread in the aftermath of particularly tropical storms. And so displacement becomes sort of a mechanism for really increasing the risk for conflict. When we talk about desiccation, we're talking really about the desiccation of the soil. We were in Malawi after 3 years. They had 3 years of basically failed monsoon rains. And so the harvests were decreased about 20% per year in these 3 years. The average person lost about 10% of their body weight during that period of time, particularly what they call the hunger times, while you're exhausted the food stores from the previous year and you were waiting for the new crop to come to harvest. And so these were things that caused migration within that central and southern African area. Refugee camps are just wonderful incubators of all sorts of conflict when you have migration. Starvation is just such a trigger for disease. Starvation always affects the kids that are under 5 before anybody else. And it's a hard thing to reverse. Once you have kids that are acutely or chronically malnourished, then they lose the eventual potential that they could reach. And that's not only in intellectual or physical, it's also in emotional control. And so it really increases inter and intra-group violence when you're dealing with people that are stunted from chronic malnutrition. Person-to-person disease is certainly there, and it's all mediated through poverty. So that's one of the big take-homes is really climate change, the final mediator for increased conflict from climate change is really through poverty, and it's climate change's effect on poverty. Yes?
Two things. Carrying capacity of the Earth. Some say it's 9 billion, some say it's 12. It isn't. Some of my friends are saying, and of course climate deniers, saying this is just a common thing to keep the population down so it doesn't reach that kind of level. With carrying capacity, will overcome the Earth and we all wrong. That's number one. So what do you think about that? And number two, I read somewhere that in Pakistan it was 124 degrees Fahrenheit. Is that pretty high for most countries?
Yeah, that was actually in April, so they got it in their spring when they hit 124, and it was a city of 1 million people. So when you're talking about air temperature like that, you're also talking a little bit of heat island effect. But it's still, how do you function at that? And that's where that decreased capability comes in. After a while, you're talking about carrying capacity, after a while the humans actually reach a limit, physiological limit to what they can adapt to. And pushing it much above 124, 125 degrees, you are reaching an absolute limit of what people can survive.
Was it a dry heat or a more humid heat?
I'm sorry?
Was it a dry heat or a more humid heat?
This is in a river valley, so it's not going to be the most comfortable heat.
Well, carrying capacity, that's a really, really tough question. What I would say is there is an absolute limit to carrying capacity of the Earth. We haven't figured out what that is. I mean, that's one of the great scientific debates among environmental scientists. What is it? And is it 9 million? Is it 12 million? To answer the question that keeps getting posed to you, though, it's just a way to take care of things. Well, the way all the other biological processes take care of that when they exceed the carrying capacity is it doesn't drop off to a nice, pleasant curve. You have what you call a massive die-off, and the curve goes like this. You have billions of units dying off, whether it's rats or whether it's people, and it goes way, way down. Then it starts back up. Now, is that something that we want to allow to happen is the question you need to ask them, no matter where the carrying capacity is. And the other thing that we can say is, absolutely, climate change is lowering the carrying capacity of the Earth. For example, he talked about human reactions and actions in a hot climate. Many of the crops are going to quit somewhere between 104 and 110 degrees. The ones that produce the most caloric value to us will not grow at any warmer than that. So what you can grow at those kind of temperatures is 75% is less valuable than what we were growing at 90 and 95 degrees. So that's what climate change does. It not only strains the humans, it's going to greatly reduce the carrying capacity, probably past what's on the Earth right now. So those are the ways that you address those questions. I've been getting those questions too, so I've been thinking about it. But absolutely saying what the carrying capacity is, well, it changes now, and it's going to go down with the new circumstances of climate. And I'm going to show that in a minute in the slide. That's why I created that. So what is carrying capacity on this one? I would not define that, but what I would ask you is, of the 7.3 billion people that are on the earth today, at what stage are those people? Are they living the good life, or are they down in Maslow's hierarchy of human need right at the bottom and straining every day to attain their life's sustaining conditions for themselves and their families? And what we're saying is, more and more people, the poverty level, are down there. Maybe not in percentages, but the total number of people that are challenged on a day-to-day basis to get enough clean water, enough food, to have basic energy needs, to have safety from disease and other challenges, such as heat. More and more people are at risk. That's the human security issue that we're trying to pose to people. Go ahead.
Real quick, and when we see that increase there in terms of the total population, one thing, again, it's an issue of poverty. If you go to Uganda, for example, their Ugandan statistics show that if you are in the top quartile of income, then you have about 2.4 children per woman. So it's barely at population maintenance. You go to the bottom quartile of women by income, and it increases to almost 8 children per woman. So, you know, and then there are reasons for it, and a lot of them are social, some of them are economic, because so many of them, the poor, are subsistence farmers. But when you look at that population increase, and it's really increasing, a lot of it's because the poverty is increasing.
Rick,
Yes?
so if the woman has 8 children, how many live beyond the age of 5?
Right now, it's actually quite a few, because there has been improvement in diseases and treatment of diseases and prevention of diseases through vaccines. So we're going through a demographic shift where the number of children that are surviving is significantly more than the early mortality was. Now, if you go all the way back to like classical times in Rome, the average woman had to bear 6 children just to maintain the population even. So you had a lot higher mortality in that time before a child or a person could reproduce. But we have improved mortality here to the point where that is also impacting, the population growth.
So, okay, what we want to do now with that as a context, and that fix in your mind, we're talking about human security as we go forward. I'm going to do a little bit of the science of climate change, so we get caught up on that, and then we'll go back to here's what climate change is going to do. How does each of those affect human security? That's the kind of approach we're going to be using now. So I have 2 sets of data that I'm going to use. I am using the last report published by the United Nations Intergovernmental Panel on Climate Change. They started and published their first report in 1990. Their work started in 1986. The 5th report was published in 2013 and 2014. There are 3 volumes to it. The one volume that I read, Tea to Green, was the scientific volume. That is 2,200 pages of scientific data. That's the basis. That is, they do not do any science. They collect science from all over the world. The best, most defensible science, they put it into one place and try to summarize what it's telling us about how the climate's changing. It is 195 countries participate, more than 2,000 scientists, all from the best laboratories and universities throughout the world have worked on this data set. The second one I'm going to use is the 4th National Climate Change Assessment, which was published by the United States government in 2018. A lot of what it uses is based on the UN, but they have vetted it again. It is published by all departments of government. NOAA, NASA, Department of Defense, Department of Energy, everybody who has any scientific background that would support looking at this data have come together and written a report, and it's specifically about how climate change is going to affect the United States. It does not spend very much time looking at it from a strategic national security standpoint. The Department of Defense takes that data and then does that assessment. The best universities in our nation participate in that, and the top private research laboratories. All of those have participated in putting on the data that I'm going to use for my assessment. So that's as good as we have. What I would say about it is, from when we published our first report in 1990 to where we are today, we are probably tenfold in the amount of information and the amount of understanding about how the climate actually works. In 1990, there was a lot of error bounds around each of the assessments and each of the conclusions that we drew, because the data wasn't as conclusive. Most of what they concluded in 1990 is still true, but what has happened is the uncertainty bounds around that understanding has come way down, because we have continued to research, we have continued to develop understanding, and what we also have are super models. Supercomputer models that can handle mega data. And really weather is about super data. You take that data and you say, now it looks like exactly it did in 1973, the temperatures, the pressures, everything looks the same. It should produce the same result. So now what we have are super data sets that say the greenhouse gases were at this level, these other factors were at this level, this is the result we're going to see. And it models it. And I'm going to show you some of the modeling results there. The error bounds are really, really closing in so that we can have much higher certainty of not only what we have now, but as a predictive model. Unless models accurately predict what's occurred in the past, and that's what you do with it. You basically put the last 100 years of data in the model and see if it can reproduce that very accurately. As the greenhouse gases have changed, as the natural sources of climate change have evolved over time. And the models can do that now. There's still error bounds, but they're much, much smaller. That's what we've learned since 1990, based on all the work that's going on. I think the UN thing is one of the great stories. Nowhere else could you get those 195 countries to sit down and talk about something. The other thing I would point out, no way in hell can you get 195 scientists together from all over the world and get them to come to a strong consensus without it being true. There's no way you can fabricate stuff across that kind of group of people. So, this is something I have added and you all haven't seen before. But to me, this is important when we talk about human security. You've all seen world maps with all the little lines on it, which are the geographic countries, the political boundaries. This is the way a physical geographer looks at the world. This is climate regions of the world. Rainforest here, savanna here. Notice how many different ones we have in the United States, just for the heck of it. Desert, steppes. What does this map reflect? It reflects, over time, for long periods of time, the precipitation, the temperatures, and how they vary on an annual cycle. That's really what this reflects. And then how it fits over the topography of the Earth. So things like mountains and lowlands and stuff change the climate because of orographics and other things like that. But over time, this is what the world looks like. So, are you going to live here? What does that say? That's a desert. You want to get to find out what 125 degrees is like? There's where you go. Right in the middle of the Sahara Desert.
Is the tundra biome changing into a taiga?
That's
Disappearing?
That's the next point. what climate change is really doing is redrawing this map from what we've lived with for, this map could have been drawn 1,000 years ago. Because this, in geologic time, changes very, very slowly. Even with natural climate change. And we'll get to that in a little bit. So this is why this affects people so much. Because where they live and how they live was determined by this map, and this is changing. It's obvious for people that live out in places like this, because sea level rise is going to cover so many of those islands. But it also affects this. And what you'll see is the desert's growing in some areas. Some areas they'll recede. But the map is different, and where people are living is going to be impacted by that, by how much water they have, what temperature they have, how much food they can produce. And that's why it's so darn important that you understand that this is a human thing. Billions of people are going to be affected. Half the world's population live within 100 miles of the coast. It's going to be 70% pretty fast. They are going to want to get water, food, and those kinds of things. Is that going to change? Absolutely. Their availability of those things change. So that's why I wanted to show this map. Did you?
Oh, I was going to go.
Go ahead.
There are two little bits of nuance. So most of the folks that really study climate change will realize that most of the change, actually the largest magnitude of the change has been occurring up in the high latitudes. So you see all the temperatures up into the Arctic and have been increasing around 4 degrees or so already.
Yeah, we're going to show those maps. So go ahead, yeah.
But one of the things is that what is abnormal for an area? So you have a lot of temperature swings up in the Arctic. You have a lot less in the area that are in the tropics. But they're having significant change there as well. And one of the things is they're not used to a lot of change down in the tropics. So there's a measure of when climate change really begins, okay? Or when it really begins to affect people, is when the average temperature is outside the 95-degree area of confidence. So basically, when all your temperatures are abnormal, then that's when it begins. And because the climate in the tropics is so stable that it doesn't take very much increase in the temperature there to bring that outside of normal. And the problem is that they're all adapted. All the crops are adapted, the animals are adapted, the people are adapted, the rainflow systems are adapted. All that is adapted to a very narrow area. So when that starts changing, then that really impacts them at a much lower absolute magnitude of temperature than it would affect people up in the north. And what that results in is that systems fail. And so one of the reasons that you're seeing people migrating up from the south is that that climate, even though it hasn't changed that much in terms of temperature, is already being significantly disrupted.
Any questions about that discussion? Standpoint? Okay. If you've been with me before, you've seen this data. This is for the deniers to prove to them the climate has changed. Get over that part. Why is the question that we're asking. And the why is both natural driven and then the human added component. It will always be that way. And the human added component now dominates everything that's going on based on the new best data that we have. We are now over 415 parts per million of carbon dioxide version of greenhouse gases, and that has pushed our temperature here. The hottest years, one thing I always point out here is this thing recorded data. I think we've done ourselves a disservice as the environmental scientists representing this data in trying to sensationalize it. And I like to avoid that. So you see the big headlines, the hottest years ever. No, the hottest years recorded. Recorded goes back to about 1880. Which in geologic time between 1880 and today is about that, or a lot faster than that. It's not very much at all. But that's the time when we had enough weather stations around the world that we could gather all those up in a year or two, add it all up and say the average temperature of the Earth was this in 1880. Before that, there just wasn't enough data. So we now see people talking about the hottest January in recorded history and stuff. Take it with a grain of salt. If they're talking about recorded data, maybe they'll mention it, sometimes they don't. They're only talking about data from 1880. Now we have great scientific data that we use before that. That's based on really, really great science. But don't sensationalize that. You know, present it to people in a way they can understand it. And I think that's a better service for us.
Take that red line and extrapolate and add methane production to it. Where would it be?
Well, that's what we call the carbon bomb. If the methane that's in the tundra and control and that is fixed in the ice and snow cap gets released, you can't do it anymore. It goes to thousands, and the temperature goes out of control, and all of the ice caps melt within a few years. And you know all the little sea creatures we find in the rocks around Kansas? Well, that was because there was water here before. It could be there again. The same amount of water is still on the Earth. It's just in different places than it was a couple of million years ago. So, this is out of the 2018 report. And what you see here is a line here, and you see a line here. This is the actual temperature and the actual modeling data. This is the modeling data and the actual data if climate was only being driven by natural causes. The real confirmatory thing came out July 2019. NBC News reported 2 independent studies were just published in that same month. One from the University of Bern, which is in Germany, and one from the University of Minnesota. They took 2,000 years of data. That's the best data they had for 2,000 years of models. And they proved that there is no way that the rate of change in temperature could be caused by any natural causes. Modeling all of the data. And if you've heard me before, I told you back then, it's the rate of change that really determines and confirms that it is not naturally caused. But well, now they have the data to support that. And so they said, this is their headline, climate scientists drive the stake through the heart of the skeptic's argument. It's just natural. No, it cannot be just natural. Jerry?
If you look at the 3 macrovic cycles,
Yeah.
which are thousands of years of recurring periods.
Oh, the shortest one's 22,000 years.
Yeah.
Let's go there.
It goes to 40,000 and then I think another
104,000. Who counts?
We should be in a long, slow cooling period, but instead we're seeing this hockey stick effect.
That's what I said. It's all natural. If we weren't having natural cooling cycles, the rise in temperature was then higher.
Yeah.
But it will always be both added together. They both impacted, but they did it in a different way. So climate change is real. Here's what climate change really is. It's warming. It's extreme temperatures. It's drying or desiccation. Extreme precipitation, damaging cyclones, flooding, storm surge, ocean acidification, which we don't think much about, but may be one of the critical elements because of what it does to food supply. And then carbon dioxide concentration in the atmosphere. Each one of those has a specific health impact. That's what Rick highlighted in a slide earlier there. And in different regions of the world, each one of these has a different magnitude in how it affects things. For example, in the tropical zones, it's going to get a little bit warmer, a little wetter, drier. In Asia, these kinds of things here, and particularly we're going to give you an example where loss of snow and ice may be the most critical thing in the Asian region. Now what they have over here is the risk and a potential for adaptation. And what you see is, when you look at this, the longer we go without action, the higher the risk and the less ability to adapt. We'll cover that a little bit more. So, we think of climate change and everybody goes with warming. In different places, warming's not a big deal, but these others take it back. In many places, warming is always going to be bad except in the just below the Arctic regions, which are actually benefit from there. The problem is, I don't think 7.2 billion people will fit in that region. It's like I used to say about in my water lectures about America. We don't have a water problem in America. We just have a whole bunch of people in the wrong places. Well, that's what the world is going to look like pretty soon. All right, so where do we go next? And where we go depends on what decisions we make right now, and then how quickly we get it implemented. What the UN did was brilliant work. They took 4 different estimates of how much greenhouse gases will continue to be emitted over time. And if we really, really, really cut down on it, we can turn this thing around. If we keep dumping at the normal levels or higher levels, we're going to see warming by 2100 of 3.2 to 5.4 degrees centigrade across the whole globe. But as Rick pointed out, and the data I'll show you shows in a minute, that's the average temperature in the world. There are places that are going to get a whole bunch warmer than that. Whereas in the tropic regions around the middle, it doesn't warm up quite as much. It depends on the decisions we make. If we make strong decisions, we can turn this thing around. If we don't, then we live with the consequences that these others produce. That's the bottom line to it. Please,
Is
sir.
it 7 degrees Fahrenheit?
This is 5.4 degrees C relative to 1850 to 1900 by 2100.
What Fahrenheit is that? Is it 7? I've been reading 7.
Yes, that's about 7.
Okay.
Yeah, 7 or 8. I have to get my calculator. I'll have to admit it. Go ahead.
Ad-lib. Just to give you an idea of what a 5 or 6 degree Celsius temperature difference is over the world, at the height of the last ice age, this is going in the other direction, but the height of the last ice age, the mean temperature is only 6 degrees different than it was, than it is now. So that shows that is an astounding amount of temperature change that we're going to have to, and our children are going to have to adapt to.
So how long do we have?
Okay, here. Perfect. If we do substantial removal, the one on the left you see over there, this is the result that you get by 2050. This is the result you get by 2099. So that's a temperature of about 4 to 6 degrees Fahrenheit. They switched to Fahrenheit. This is out of the US data, so they switched to Fahrenheit because they know people like me can't do the calculations. If we don't make the big change, in 2050 you see it's much warmer across the whole nation by 2050. By 2100, we're 10 degrees Fahrenheit warmer throughout the United States. Many places become uninhabitable, basically, when you get to that. From a world scale view, the same data set, optimistic, pessimistic, and what you're looking at here is numbers going as high as 11.7 degrees C. C. In the northern climates. And those are already 4 degrees warmer. Yeah, there's this feedback mechanism. As the ice melts in its water, then it absorbs more heat because the sunlight is reflected off the ice. It's 90% absorbed by the water. So it accelerates much, much faster. The more ice you lose, the more heat you get, the faster the temperatures warm in that part of the world.
You can turn it.
So what percentage of ice North Arctic would be lost in the high CO2 scenario there?
It's all gone.
All the ice?
It's gone. You might collect a little up in the winter, but it's gone. Every summer, it's gone completely. All that converts to seawater. Okay. Let's make it real. So, we'll go back over here. In the boxes, I have each of the primary effects of climate change. Damaging cyclones, precipitation, sea level rise, loss of snow and ice cover. We call that the cryosphere change. Extreme temperatures, drying, scattered across this map. What you see here is the Tibetan Plateau. What I'm showing you is really a watershed. 7 of the major rivers of the world come off this one watershed. The Yangtze, the Yellow, Irrawaddy, Brahmaputra, some other places I can't pronounce, Indus up there. From a strategic standpoint, I look at this and I get scared. And here's why. 3.2 billion people live in that watershed. That's nearly half the world's population right there is affected by one change. 3 of the world's largest armies are there. China, India, and Pakistan. China and India are the 2 largest. We're 3rd, Pakistan's 4th. 3 of the 5 largest nuclear powers, and I don't mean reactors to make energy. Nuclear weapons, Russia is #1. China has them, Pakistan has them, and India has them. They don't politically get along very well already. Water is a critical resource there already because of the expanding populations that are there. It's one of the fastest growing regions of the world. Then we have climate change. And the biggest, they're all bad, but the biggest is the loss of ice. The rates that we're losing ice and snow cover in the Himalayas and in every other major ice cap around the world is tremendously faster than it's ever been. We used to measure those things in like 0.1% per 100 years. And now they're being lost at 3 to 5% in a decade. That is the greatest water resource management system that the world has. It collects the water up in the wintertime, it releases it in a more slow fashion in the summertime, so that it perennially delivers water to those 3 billion people. What climate change does is it collects up snow and ice in the winter, it releases it in massive numbers during the springtime, and all of these rivers flood, and hundreds of millions of people are displaced or damaged or put at human health risk. And by the end of the summer, some of these rivers can dry up and cannot provide basic human needs and cannot certainly be available to produce crops. And most of the agriculture is regionally contained there. That's why this is such a great, it's both a national security issue for us because of the massive amount of military power that exists, and quite honestly some scary people holding the triggers to nuclear arsenals, but I don't think we can say anything about that at this particular moment, about who's got the trigger to the nuclear weapons. But that's why we look at this and then we start doing the human security analysis. Go ahead.
I know that China does a lot of engineering of dams for flood control like the...
No, they're stealing water.
Is it likely that since they all start in Tibet that they'll do a lot more damming of the rivers?
They're in there right now. They're putting them, it's not just the ones on the Yellow and the Yangtze, they're up in the mountains. Some of you may have heard my sick joke before. I don't think China has any animosity to the Dalai Lama. They just want all his water. They want it all. And they're taking water away from India right now in some of the stuff that they put in. They've got a big arid spot in the western part of China that can produce a massive amount of food for a big population. All they need is water, and they know that. And they're not afraid to go get it. So,
Jared?
In other talks, you've talked about Sudan damming the Nile River.
no, Ethiopia's down in the Nile.
Okay, all right, Ethiopia stealing water from Egypt.
No, the water all falls on Ethiopia. They're just keeping what they got.
Oh, okay.
Yeah, it's just that Egypt says they won't allow that. If they have to, they will go to war over that water because they've got a massive population that they need to feed. Almost no water falls on the whole country of Egypt. Aswan Dam is where they have all their water that comes through the Nile. The rainfall at Aswan, Egypt, to one of those weather stations I told you about, on an annual basis is 0.00 inches per year. It rains once or twice every 3 or 4 years. But all the water that 100 million people live on go through that dam. But it came from Ethiopia, it came from South Sudan, and it came from the tropical regions in the middle of Africa. It's not their water. But if you ask an Egyptian, and I have, the Nile is Egypt and Egypt is the Nile. They will fight for every bit of water they need. So that's I use that as an example.
Isn't there something similar going on in Turkey with the Euphrates and the?
No, the Turks are damming. They have a plan. They call it the Anatolia Project. It's to put 23 dams in eastern Turkey to collect up the water that goes into the Tigris and Euphrates rivers. You may have heard of those. And divert it to the middle of Turkey to grow food, to produce hydroelectric power, to manage the water better. What do you think the Kurdish thing is about? It's not about the Kurds, it's about the water. The Kurds live where the water is. They're mountain people. They live in the mountains of Turkey, they live in the mountains of Iraq, and they live in the mountains of Iran. It's about water. If they put in all of those dams, we did the calculations, and the Tigris and Euphrates will lose 90% of the water that comes into Baghdad. Basically, they're going to go dry. 95% of the water in Syria comes from Turkey. Can it get worse? Yes. Without water, it really does get worse. The rest of Syria has to leave because there's no water.
Question.
Go ahead.
So in the area that you showed before with the high CO2 levels and ice disappearing, so what's that going to do to sea level?
Depends on the rate. It's going to continue to rise.
How much?
Well, the prediction is right now, if you don't have a major catastrophic event, such as the carbon bomb that we're talking about 2,100, and the estimate's around a meter. That doesn't sound like very much, 3 feet. If you put it into perspective, that will displace 35 million people in just Bangladesh. That's where we've done the best calculations, because I've worked with the Bangladesh Institute for Peace, and they've done some good work. 35 million in Bangladesh. Take that number and move it to the number from Pakistan, the river valleys that have to leave, from India, the valleys that have to leave, and we're getting into hundreds of millions of people that will displaced by 2100. Good question.
What is the effect of desalination? I'm sorry.
Go ahead.
What is the effect of desalination on giving the water where it's needed?
We don't have a system that desals without producing a lot of greenhouse gases. This is one part of it. We just trade water for energy. You either use reverse osmosis, which uses a lot of pressure, or you take it all the way to distillation, which means you have to dry the water and then recover it without the salt. Both of them are huge injuries. People are working like crazy trying to find ways to do it without using much energy. Probably the best scientists in the world are the ones that are in Israel trying to work on that, because they recognize if they can solve the water problem, then they have 10 times as much land that's just as valuable as the land they're fighting over.
I didn't even put this together, but I was watching the local news tonight, and the Missouri River has had 279 days above flood stage. Just right here in Kansas and Missouri, 279 days it's been a flood stage.
Well, put that together with the fact that the farmers in western Kansas don't have
That's what
water.
they're talking about now.
Yeah,
That we're gonna
that's
be
it.
able to-
Because the aquifer is drying up, but the flooding of the water, which actually runs the water off faster and doesn't allow it to go into the groundwater, so we got a double-edged problem. They're both driven. One of them's driven heavily by climate change, the flooding. That's like I was describing in the Tibetan scenario. The other side is human-driven, where we've overpumped the aquifer for a very long period of time in the agriculture region that's supported by that aquifer. It just can't recover as fast. But it doesn't help that the water's all running off rather than infiltrating in a slower pace like it used to.
It's maldistribution, just really with the increased rain events and change in the patterns. So like in the, when we're talking about the Tibetan Plateau, in 2010, Pakistan had really devastating floods. They affected 20 million people in Pakistan. That was more people than were affected by the Haitian earthquake, by the tsunami combined.
That's why that region of the world is so scary, because so many people live at the very lowest level. I say they live in the margins, the places where, we like to draw the 100-year floodplain and say, don't build your house in there. They live in the 1-year floodplains, because there's nothing left when you have, like in India, 1.3 billion people and a high birth rate. All the good stuff used up. Jerry?
I remember when that flooding in Pakistan occurred, I remember the headline that 25% of Pakistan was underwater.
Yeah, astounding floods. And then it's one of the things when the marginal areas are always occupied by the poor also. So when you're talking about flood-prone areas, those will be occupied by the poor because the people with enough money and resources won't live there. You go to the desert areas, or the desert will have or the semi-arid places will have much greater percentage of the poor. You go to places that are storm-prone. In the Philippines, lots of tropical storms come through there. The land that is the cheapest is that which is right up next to the ocean, as opposed to the U.S. So these are things that are just going to, when you're talking about marginal, you're talking about the marginal land, you're talking about an area where the poor are going to suffer even more.
There's an example in the United States. When Katrina hit New Orleans, what got flooded? Those districts that people shouldn't have been building in before, but everybody turned away because the people didn't have any place to live, so they let them build in the lowlands. Those lands were supposed to flood when the big floods came. We knew that. But that's the rest of the world that lives like that.
Yes?
Please put the microphone a little closer.
Okay.
Oh, that's, sorry.
So it seems like everything's going back to too many people. Too much consumption, too many uses of resources caused by too many people, too much human population. So if that's the root cause, why don't you ever hear anybody talking about tackling that problem?
Okay, so we're talking about overpopulation as being a root cause of a lot of the ills that are going on. And that's true. But is it going to be affected by, say, people in the U.S. and who may, say, ethically choose not to have children due to its effect on the climate? Well, probably not. That probably won't have a big effect. But what does actually control population? So the things that control population are several that have been shown throughout to work. They are educating girls. They are improving the standard of living, particularly for women, particularly through jobs for women, and provision of long-acting reversible contraceptives. So those are three things that you can do that are going to apply really more to the majority world that's outside of the US, outside of Western Europe, that have been shown to effectively reduce birth rates. So, we can do it as fast as we can. Fast enough it means that you have a fixed point that you're kind of working against. Yes? Oh, okay. Yeah, we're running short. Okay.
So I think this is what we're talking about here. So how do we fix some of this? So let's just move on to this one and start. What you got are the opportunities for mitigation. That means reduce the impacts by, okay, I got it. Mitigations mean reduce greenhouse gases. Number two, right there, population control. If we can slow down the growth rate, the carbon demand of each of those new people doesn't appear. We've got a lot of monitoring to do to find out where it's getting bad most quickly so that we can do the adaptations as things change. and continued research on things like carbon capture and stuff. We're looking for opportunities through technology, but mitigations have to start now because of that carryover of a 100-year life cycle I was talking about. Then adaptations, we're talking about what we're going to have to live with for the next 100 years. And there it is again, man. Population control is still there. These kind of things, and then we look at these kind of actions where we're going to be dealing. We've done them before. Rick and I have been involved in them. We've never seen these scales before. He and I worked on the Rwanda mission. He was downrange. I was living the good life in Stuttgart. But we had 1 million people that they were working with down there, and 5,000 a day were dying when they started the action. Now we're talking about hundreds of millions or more. I think the recent UN report said something like 300 million people by 2100 may need resettlement and stuff like that.
And then it doesn't even talk about all the other species that are going.
No, we have just ignored the rate of extinction that is going on right now, which we don't know that it's ever been that high before. I've never seen any data that said the extinction rate. And what I always point out, point out is, when we do environmental science, one of the things we always use as a metric is the diversity of the population, whether I'm looking at a stream, or I'm looking at a number of species in a forest, or I'm looking at the number of animals if you're managing animals. You look for the diversity. The more number of kinds of species that a region is supporting, the healthier it is. Killing of these species is violating our basic understanding of how our whole earth works. So we're down to we're the only species left and we won? No, I don't think so. It's just all of the data tells us we're more and more in a less stable, less secure, less human supporting environment, and we keep ignoring the data set. These are the kinds of things we have to be involved with. We have to be involved in actively, not wishing for. We've got to get at these things is the only way you can say that. At the mitigation types of things, and we have to change our ways to recognize how the adaptations are going to affect us all. So those are my closing comments. Now, Rick, you can.
Well, particularly with regard to the adaptations, we're talking about population control, we're talking about flood control, humanitarian support. These are all things that really, if you can work on the resilience of the population, you can work on reducing poverty levels. Reducing poverty is actually something that we've been fairly successful at as a planet over the last 30 or 40 years. We've reduced severe poverty, particularly in India, particularly in China and other places. But by reducing poverty, you'll reduce population. Reduced poverty will allow more, it will reduce migrations, the flood controls, certainly you'll be able to get people into better areas, humanitarian support, and frankly, well, refugee resettlement, we're still going to have to do it anyhow. But yeah, the goal is to really address poverty.
So let's summarize. I did talk a little bit about the security implications. We, the military, have to recognize that it's more than having bigger guns than everybody else. And I think we're getting to that point now. We got to change the way we operate. We got to be good stewards of the environment. And we have to prepare for, when we start talking about mass refugee populations, the reason we were there, because we work for the United States Army. When you talk about mass refugee, mass resettlement, we're the guys that pick up the 911 call for that, because there's nobody else in the world that can do that. Nobody else has the resources, the trucks, the planes, the people that can deploy and do the engineering and do the medical for those kinds of things. We have to recognize that and decide what we as a nation are going to be able to do to support people around the world. We're working, the goal is stable human communities around the world. That's real peace. Because people who are stable, have what they need to survive, and don't feel a threat to security from disease, from other kinds of stressors, they have no intentions of fighting anybody. One thing I have found out in my 58 countries now I've been into is people are a whole lot alike, a whole lot more alike than they're different. And those basic, they love their kids, they love their families, and they want to be friends in the dominant species, even in places like China that I've been. So establishing those stable human conditions is the most peaceful thing we can achieve, in my view. Environmental degradation, all environmental security issues, when you put them together, that's a goal to work on those, because those are destabilizing. And then when we get down to climate change, we really talked about those as in the last slide. Adapt and mitigate. Those are words that came out of the UN work too. That's what the UN and the rest of the world has agreed we needed to do. Climate change is a world-scale issue. With the greatest army in the world, Air Force, Navy, we can do everything we can in the United States. We could even do everything that we could for reducing greenhouse gases and working on that. And we still lose unless we take a leadership role and bring the rest of the world along with us to achieve those goals. And what's happening is they're sitting waiting for us to do something. And we're sitting on, well,
Yeah.
we've got our heads in a place that doesn't have a lot of sunshine, in particular.
It ain't a hole in the ground.
Vote.
Yeah.
And as Rick has pointed out again and again, immediately it's the weakest nations and the poorest people that are going to suffer, already suffering.